Yesterday we took a look at the arithmetic sequences and series, and today we're going to take a look at the geometric. So, we're going to take a look here at these, and all these geometric sequences, what's different than them than the arithmetic ones? Well, we'll notice here this is times 5 times 5. This one is times -2 times -2. Divide by 3 or times 1/3. So these sequences all have a common ratio. Now, sometimes you might look at one and you might be unsure what the ratio is. For example, what if we had 1/3, 2/15, maybe 4/75? Well, what is this ratio? Well, how we can find it, to find any ratio, we take a term and divide it by the term before. So we could take 1/3 divided by 2/15, or excuse me, I have that backwards here. Our term, that's not the one before, so we'd have 2/15 divided by 1/3, and to divide fractions we multiply by the reciprocal times 3 over 1. So we have 6/15, which reduces down to 2/5. It's a little easier on these to say. We take any term, so 125, and divide it by 5. Well, actually, this one I think is supposed to have a 25 in there, and we get so 125 divided by 25, and we end up with 5. Sorry about that. You're seeing these mistakes. This one we could take -6 divided by 3, and we get -2. But we can choose any term. If you chose -24 divided by the term before, and we get that common ratio. So this one, 3 divided by 9, well, that's 1/3. We could take 9 divided by 27, and that's 1/3. So our common ratio, you take a term divided by the previous term, and you get your ratio. So to find the rule here, it's our first term times our ratio, 1 less than the number of times. And that makes sense to get our, let's take out one that is correct here, to get our n equals 1, 2, 3, 4th term, we start with our first term, and then we multiply it by -2 3 times, hence that power here. So we need to show that this one is geometric. So first we have to find our ratio. Well, let's see, 4 divided by 8 is 1/2. Or we could take this other one, we could take 2 divided by 4, and we end up with 1/2 as well. So it's a common ratio of 1/2. Well, the nth term, so u sub n equals our first term of 8 times our ratio of 1/2 to the n minus 1. And then we need to find our 12th term. So u sub n equals 8 times 1/2 to the 12 minus 1. And then we can jump to our calculator here. Eight times 1/2 to the power of 11, and we end up with 1 over 256. So this next one that we're going to take a look at, we have these 3 values. So here is our first term, our second term. I'm going to divide these up in our third. And we have to find k. Well, we know it's times some ratio each time. So we could come up with a formula. We could say k minus 1 times our ratio gives us 2k. And we could look at the second one, 2k times that same ratio gives us 21 minus k. Well, let's see, let's do some solving. Let's get our k's on the same side. So our ratio equals 2k over k minus 1. And over here, well, let's get our k's on the same side. Our ratio equals 21 minus k over 2k. Well, and that makes sense. It's our term divided by the previous term, 2k divided by k minus 1. So we have this, our ratio, one way is 2k over k minus 1, but written a different way, it's 21 minus k divided by 2k. And now we need to solve this. Well, let's see here. 2k times 2k, so 4k squared, equals k minus 1 times 21 minus k. So we have to distribute this out. So we have 21k minus k squared plus 21 plus k. So on this side we have 22k minus k squared plus 21. Well, this is a quadratic here, so if we set it equal to 0, plus k squared minus 22k minus 21. So if we do the same thing over here, minus 22k plus k squared minus 21. So we have 5k squared minus 22k minus 21 equals 0. And then you could do that quadratic formula. So k equals the opposite of b plus or minus the square root b squared minus 4ac all over 2a. And if you do this, you get two answers. K equals 7/5 and k could equal 3. Now this next one, we have to find the nth term. So let's take a look at this here. Well, I like looking at these in tables. So n, u sub n. We don't know our first term, but we know our second term is -6. We know our fifth term is 162. So let's see. What is our difference here? -6 to 162. So we're going up 168. And 2 to 5 is 3. So in 3 r's, 3 times our ratio there. So we're multiplying by r 3 times. So 168, that would be, let's see, that won't be r cubed there. Our ratio, it would be 2 times r cubed would give us something seems a little off here. So we start with, oh, -6, that's it. Okay. My bad there. Because if we take this -6 and we multiply by r 3 times, we get, we end up with -6 times r cubed. So let's see here. If we divide this by -6, and something still seems off here. So we end up with, let's see, what's 168 divided by 6? 28. So 28 equals r cubed. And then we take the cubed root, so we have the cubed root of 28. And I thought it turned out to be a nice number, so let's double check everything here. Let's make sure this thought process is right. So, if we start at -6 and we multiply by r, we'd get our third term. By r again, we get our fourth term. By r again, we get our fifth term. So -6 times r cubed gives us 162. That's it. So we're not finding the difference there, just how do we get there? Well, we start at -6, multiply by r 3 times, and we end up at 162. So if we divide this by -6, we end up with r cubed equals -27. Take the cubed root, and we end up with r being -3. So if we have to find our first term, we can divide by -3, so r is 2. So 2 times -3 to the n minus 1, that gives us our u sub n. And then the last thing we're going to take a look at here, compound interest. And we've talked about this before, where this is our principal, our rate to the number of years there that we've invested. So how much should you invest now if you want a maturing value to be 10,000 in 4 years' time? So you want to have 10,000 equals, we don't know what we're starting with. Our rate is 0.85 to the fourth. So you have to divide by 0.85 to the fourth, divide by 0.85 to the fourth. So we have 10,000 divided by 0.085 to the power of 4. And something seems a little off there. Let's double check. Did I type everything in right? Oops. Let's see, where'd it go? So we want $10,000 equals our starting rate times 0.085 to the fourth. What did I type in wrong? That seems like a crazy, oh, it should be times 1.085. Because our rate, we have to keep counting that year. So that's it. So if we go back up here, hit enter, delete, we have 1. So we end up with $7,215.